this new video, please, we are going to advise you to subscribe and press the subscription button and comment. And you can also share this video. Please, you can subscribe so that you can get more video on topics on physics, chemistry, maths, biology, English to pass your WAEC and JAM, including JUPEP A-level. In this video, we shall discuss hydrocarbon compounds. Hydrocarbon compound. What is hydrocarbon compound, or what are hydrocarbon compounds? Hydrocarbon compounds are compounds that contain carbon and hydrogen. Any compound that contains hydrogen and carbon is known as hydrocarbon compounds. Any compound that contains hydrogen and carbon is known as hydrocarbon compound. And this hydrocarbon compound can be divided into two. Hydrocarbon compound can be divided into two. I told you that hydrocarbon compound means compound that contain hydrogen, carbon, hydrogen and carbon. Hydro is hydrogen, then carbon. Compounds that contain hydrogen and carbon. Let's continue. Then we have hydrocarbon compound. I said can be divided into two, which are hydrocarbon compound. We have hydrocarbon compounds can be divided into two. We have aliphatic hydrocarbon. Aliphatic hydrocarbon. HC means hydrocarbon. And we have aromatic hydrocarbon. Aromatic hydrocarbon. This aliphatic hydrocarbon is an hydrocarbon that occur in long chain. It could be long chain, it could be short chain. That means aliphatic, long chain, open chain hydrocarbon. This aliphatic hydrocarbon can be divided into two. It can be divided into two. We have a cyclic hydrocarbon and we have cyclic hydrocarbon. Cyclic hydrocarbon and a cyclic hydrocarbon. A cyclic hydrocarbon is what? Open chain hydrocarbon. While cyclic hydrocarbon is what? Is closed chain. It occurs in ring. It occurs in ring. An example, we have cycloalkane. It's an example of what? Cyclic hydrocarbon. Cyclic hydrocarbon. Then this cyclic hydrocarbon, we have three, which are what? Alkane. We have alkene. We have alkyne. This cyclic hydrocarbon, we have homocyclic hydrocarbon, and we have heterocyclic hydrocarbon. We have homocyclic hydrocarbon and heterocyclic hydrocarbon. I will explain the meaning of homocyclic and heterocyclic. And before I do that, let me quickly explain aliphatic and aromatic one more time. I told you aliphatic hydrocarbon. First of all, know that hydrocarbon is a compound that contains hydrogen and carbon. That is hydrocarbon compound. Then aliphatic hydrocarbon is an hydrocarbon that occur in long chain, or it could be what? Short chain. And it is an open chain hydrocarbon. Aliphatic, long chain or short chain. Long chain or short chain. And it can be divided into two. We have cyclic and what? Acyclic. I said cyclic hydrocarbon, they occur in what? In a closed chain, in form of ring. In form of what? Ring. For example, when you have something like this, this is what? An example of a cyclic hydrocarbon. Cyclic hydrocarbon is an example of cyclic hydrocarbon. Example. Another one, you can have something like this. That means in form of ring, cyclic hydrocarbon. That means we have cyclic hydrocarbon. It's an example of what? This is what they call cyclic hydrocarbon. Then from here, I said this cyclic hydrocarbon, is a closed chain which we can have homocyclic and what? Heterocyclic. What is homocyclic? Homocyclic means what? It only contains carbon. Carbon. There's no other what? Element. No other atoms of what? Element in it. For example, when you have butane, when you have this butane, cyclobutane, cyclobutane, this cyclobutane. This is an example of what? Homocyclic. It only contain what? Carbon atom and what? Hydrogen atom. But when you have a cyclic hydrocarbon with another atoms of element like oxygen, like nitrogen, is known as what? Heterocyclic. That means it has contained another word form of what? Element. That is heterocyclic. But I will explain more on that as we are what? Moving on in this video. We have cyclic, which can be divided into what? Homocyclic and what? Heterocyclic. We have acyclic. Acyclic is divided into two: alkane, alkene, alkyne. And there's a question I want you to example of this. I can say example of what? Cyclic generally. We have cycloalkane. Cycloalkane is an example of what? Cyclic hydrocarbon. Cycloalkane is an example of what? Cyclic hydrocarbon. There's a question that came out in JAM for alkane to form cycloalkane. How many atoms of hydrogen? How many atoms of hydrogen are lost? We have option A, 3, option B, 4, option C, 2, option D, 1. For alkane to form cycloalkane, alkane is an example of acyclic. To form cycloalkane and a closed chain, acyclic is an open chain. Cyclic is a what? Closed chain to form ring. Cyclic, closed chain to form ring. Acyclic, open chain. Open chain, I will give you now. For alkane to form cycloalkane, how many atoms of hydrogen is lost? In that case, look at this. Look at this. When you have this, let me write it here. When you have, let me take this alkane. When you have ethane or ethane, that means 6 carbon of alkane. This is ethane. For this ethane to form cyclohexane, that is cyclohexane is an example of what? Cyclic hydrocarbon. For this ethane to form cyclohexane, what are you going to have now? CH2, 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 then CH2. Look at it. This is ethane, which is CH3. I'm sorry. CH2, 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 CH3. This is ethane, cyclohexane. How many carbon of hydrogen? 1, 2, 3, 4, 5, 6. How many hydrogen do we have? If you calculate, we have 14. But look at this. How many atoms of carbon do we have? We have 6 atoms of carbon. 1, 2, 3, 4, 5, 6. How many atoms of hydrogen do we have? 2 plus 2, 4, plus 2, 6, plus 2, 8, plus 2, 10, plus 2, 12. That means, and in this one, in this number, this is cycloalkane. For this alkane to form cycloalkane, you can see that 2 atoms of hydrogen is lost. Take note of that. Is there your jam pass question? For alkane to form cycloalkane, 2 atoms of hydrogen will be what? Will be lost. Take note of that. You can see this one is C6H14. This is what they mean by open chain. It is open. But this one is what? Closed chain. Closed. It is closed. Every part of it is what? Closed. That is cyclic what? Hydrocarbon. Closed chain. While acyclic is what? Open chain. Acyclic is what? Open chain hydrocarbon. Please take note of that. And for this acyclic to form cyclic, two atoms of hydrogen is lost. Take note of that. These are what we have under hydrocarbon. I said it can be divided into two. We have aliphatic, aromatic, then aliphatic into acyclic, cyclic. Acyclic, we have alkane, alkane, alkyne. Cyclic, we have homocyclic, and we have heterocyclic. Example of cyclic, we have cycloalkane. You know that cycloalkane. Then let us go to aromatic hydrocarbon. Aromatic. Example of aromatic hydrocarbon is a benzene and its derivative. Benzene and its derivative. These are examples of what? Aromatic hydrocarbon. An example of aromatic hydrocarbon is what? Benzene and its what? Derivative. And for compound to be aromatic in nature, there are some characteristics that compound must exhibit. Take note of that. For a compound to be what? Aromatic in nature, there are some what? Characteristics that compound must exhibit. Let me give you characteristics that a compound must exhibit to be what? Aromatic in nature. Number one, it must occur. It must occur in cyclic nature. In cyclic nature with one or more bonds in an alternate position. In an alternate what? Position. That's it. The first one, it must occur in cyclic nature. That means it must be what? Cyclic nature. It must be in what? Cyclic nature. That means in a closed chain. Cyclic is what? Closed chain. Forming ring, cyclic, closed chain. It must occur in cyclic nature with one or more bonds in an alternate what? Position. Take note. Number two, take note of that. Number two, it must be planar. Take note. Planar, that means it must be flat. It must be what? Planar. It must be planar. And have the tendency to show resonance. As we are going in this video, in this journey of hydrocarbon compound and its derivative, we are going to talk about what? Resonance of what? Of aromatic. Take note. It must be what? Planar and have the what? Tendency to show what? Resonance. Number three, it must obey Ockhams what? Rule. It must obey. Number three, let me write it here. Look at it here. It must obey. Ockhams rule. It must obey Ockhams what? Rule of what? 4n plus 2. It must obey Ockhams rule of 4n plus 2. It must obey Ockhams rule of 4n plus 2. These are characteristics that a compound must exhibit to be what? Aromatic in nature. The first one, it must occur in cyclic. Cyclic means what? Closed chain. That means in circular form. It must be natural. It must occur in circular form naturally with one or more bonds in an alternate position. Number two, it must be flat. That is planar and have the tendency to show what? Resonance. Number three, it must obey Ockhams what? Rule. Take note of that. This is what? Characteristic for a compound to obey, to exhibit what? To be what? Aromatic in what? Nature. Take note of that. Please, let's move forward. Let's move. Really? Let's move. Okay. Okay. Listen. Why do we now have more of hydrocarbon compounds and its derivative? Don't forget, under this compound, hydrocarbon compound, when you have the study of hydrocarbon compounds, when you have the study of hydrocarbon compounds and its derivative and their derivatives, the study of what hydrocarbon compound, I'm sorry, the study of hydrocarbon compounds, the study of hydrocarbon compounds and their derivative is known as organic chemistry. Take note of that. The study, when you study hydrocarbon compounds and their derivative, when you study hydrocarbon compounds and their derivative, that is known as what? Organic chemistry. And I told you hydrocarbon compound is a compound that contains only hydrogen and what? Carbon. Then when you study that hydrocarbon compound and its derivative, that is known as what? Organic chemistry. What are the derivatives of hydrocarbon compound? When you have alkanol, it's a derivative. When you have alkanoic acid, it's a derivative of what? Hydrocarbon compound. When we study hydrocarbon compound and its derivative, that is known as what? Organic chemistry. Take note of that. Then why do we have so many organic compounds? Organic compounds are more. They are more. They can be found anywhere you go. Why do we have what? More of organic compound than inorganic compound? Why? Number one, reason we have more of organic compound than inorganic compound. Why do we have hydrocarbon compounds and their derivative more than inorganic compound? Why do we have organic compound? That is organic compound. That is hydrocarbon compound and its derivative more than what? Inorganic compound. Why do we have that? Number one, the ability of carbon to catenate. One of the reasons, the ability of carbon to catenate. The ability of carbon to what? Catenate. That phenomenon is known as what? Catenation. What is catenation? Catenation. Catenation is the ability of carbon to form long chain or cyclic compound. The ability of what? Carbon to form long chain or cyclic, that means circular what? Compound. That is known as what? Catenation. And is the only element that can do that can catenate. It has the ability to form long chain. It can form long chain and form a circular what? Hydrocarbon compound or organic compound. Take note. That is one of the reasons we have more of what? Of organic compound. Number two, it has the ability to link up, to combine with other elements. Carbon has the ability to combine with other elements. Carbon, that means the ability of carbon to catenate, that's first one. Carbon has the ability to combine with other elements. It has ability to combine with what? Other elements. It has ability to combine with other elements. Number three, it has ability to form multiple bonds. Carbon has ability to form multiple bonds. That's one of the reasons we have so many organic compounds. Carbon has the ability to form multiple bonds. multiple bond. That means it can form double bond. It can form double bond with its what? Atom, carbon-carbon. It can form what? Triple bond. It has the ability to form double bond, triple bond. That means it has the ability to form multiple bond. That is why we have so many what? Organic compound. The fourth one, it is tetravalent in nature. Carbon is what? Tetravalent in nature. Carbon is tetravalent. Tetravalent in nature. Is tetravalent in nature. These are the reasons why there are so many organic compounds everywhere you go. Take note of it. This one came out in Jan and it came out in NECO. That was 2020 or 21. NECO. And it's a regular question in Jan. They will say, which of the following elements can catenate? Which of the following elements can catenate? The answer to that question was carbon. Is the only element that can catenate. Then they will say, or the question can come in another form. The ability of carbon to form long chain or cyclic or circular compound is known as what? Catenation. Catenation. Take note of that question. Then let us go to the general property of hydrocarbon compounds and its derivative. Let us go. Let us move. General properties of hydrocarbon compound and its derivative. That means general property of organic compound. General properties of organic compound. General properties of organic compound. General properties. General properties. General properties of organic compound. I told you organic compound is what? Hydrocarbon and its derivative. And the study of what? Hydrocarbon and its derivative is known as organic chemistry. Please take note. Organic compound means what? Hydrocarbon and its derivatives. Hydrocarbon compound and its derivative. Then the study of hydrocarbon compound and its derivative is known as what? Organic chemistry. Organic compound means hydrocarbon and its derivative. Hydrocarbon compound is a compound that contains hydrogen and what? Carbon. But when you have other elements in it, it can form derivative like what? Alkanol, alkanoic acid, ketone, aldehyde. Take note of that. Carbohydrate. Take note of that. Then general properties of what? Organic compound. Number one, covalent nature. They exhibit covalent bond. That means they have covalent bond. They exhibit what? Covalent bond. They exhibit covalent bond. That means the first one, they exhibit what? Covalent bond. That means they form covalent molecular compound. Organic compounds are molecular compound. Take note of that. It's a question in what? GC 2023. It's an example of organic compounds and molecular compounds. Molecular compounds are compounds that exhibit covalent bond. Molecular compounds are compounds that exhibit what? Covalent bond. This organic compound, they exhibit what? Covalent bond. They are covalent in nature. Why? Because non-metals combine with non-metals in which there's what? Sharing of what? Electron. They share electron. And it has a big intermolecular what? Force. Take note of that. That means they have, because of their, one of their properties is that they exhibit covalent bond. That means they have covalent nature. They are covalent in what? Nature. They are covalent in nature. They are covalent. Covalent in nature. They are covalent in nature with weak intermolecular force. with big intermolecular word force. They are covalent in nature with what? Big intermolecular word force. Take note of that. Number 2, let us look at their solubility. Solubility. Take note of this. Take note of this. Take note of this. Please, I want you to take note of this. Note. 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 Non-polar solute dissolve in what? Non-polar solvent. Take note of this. Solvent. Non-polar solute dissolve in non-polar solvent. Why polar solute dissolve in what? Polar solvent. Take note of this. Non-polar solute dissolve in what? Non-polar solvent. Polar solute dissolve in what? Polar solvent. Example of polar solute that has what? Both positive and what? Negative what? Pole. Polar solvent, example that has both positive pole and what? Negative pole. Example of polar solute, for example, we have sodium chloride. It's an example of polar solute. And it is what? Soluble in what? Polar solvent, such as what? Water. Water is an example of polar solvent. That's why I say polar solute dissolve in what? Polar solvent. But non-polar solute cannot dissolve in polar solvent. It's not possible. Non-polar solute cannot dissolve in polar solvent. Take note, cannot dissolve. Non-polar solute cannot dissolve in polar solvent. Therefore, these hydrocarbon compounds and their derivative, they are non-polar solutes, except of those that contain polar molecules. Hydrocarbon compound, they are what? Non-polar word compound, non-polar molecules. Hydrocarbon compounds are non-polar molecules because some of them are solutes, some of them can be what? Solvents. Take note. They are non-polar what? Molecules. Hydrocarbon compounds are non-polar molecules. How do we know that they are non-polar molecules? How do we know? They are non-polar molecules, hydrocarbon compounds, right? Hydrocarbon compounds are non-polar molecules. They are non-polar molecules. They are non-polar what? Molecules. Hydrocarbon compounds are non-polar molecules. Take note of that. They are non-polar molecules. Let me explain better. They are non-polar molecules. Hydrocarbon compound, I told you when you have carbon combining with what? Hydrogen. You have this. Carbon combining with hydrogen. You now have what? Methane, for example. You have methane, for example. Can you see? This is non-metals combining with hydrogen, which is also non-metal. The electronegativity of carbon is 2.5. The electronegativity of hydrogen is 2.1. The electronegative difference between the two, is what? The bigger one, 2.5 minus 2.1. That means the electronegative difference is what? 0.4. Then when you have electronegative difference to be less than and equal to 0.4, that molecule will be what? Non-polar. Take note. When electronegative difference is less than or equal to 0.4, that molecule will be what? Will be non-polar. And if you see this, carbon and hydrogen, the electronegativity of carbon is 2.5. Electronegativity of hydrogen is 2.1. Then the electronegative difference is what? 2.5 minus 2.1 is what? 0.4. Is equal to 0.4. Such molecule is what? Non-polar. And this hydrocarbon compound, they are non-polar. Since they are non-polar, they cannot dissolve in what? Polar solvent. They can only be dissolved in what? Non-polar solvent. Take note. Why? Because they have electronegativity difference to be what? Equal to 0.4. And when you have that, such molecule is what? Non-polar. That is why hydrocarbon compounds are what? Non-polar. They can only be dissolved in what? Non-polar solvent, such as what? Benzene, which is a solvent, tetrachloromethane, trichloromethane, which is known as chloroform. These are the solvent. They are non-polar what? Solvent that can dissolve what? These non-polar hydrocarbon compounds. Take note of that. Another reason is that they are what? They cannot form. Listen, is there your past question? Hydrocarbon compounds, they cannot form hydrogen bond with water. Take note. They cannot form hydrogen bond with what? Water, because they are non-polar. And water is what? Polar. They cannot form hydrogen bond with water. That is why they are not soluble in what? Polar solvent, which is water. Water is a polar solvent. They are not soluble in water, which is polar solvent. Why? Because they cannot form hydrogen bond with what? Water. Take note of that. They can only be dissolved. They are soluble in what? Non-polar solvent, such as this. That means methane, as an example, is soluble in what? This polar solvent. Take note of that. They are soluble in polar solvent because they are what? Non-polar. But there are some derivative of what? Of this hydrocarbon compound that are soluble in water. For example, arcanol. Arcanol is a derivative of hydrocarbon compound. This one is soluble in water. Arcanoic acid. Arcanoic acid is a derivative of what? Hydrocarbon compound. It is soluble in water. Why? Because of their functional group. This one is what? Hydroxy functional group. This one is what? Carboxy functional group. This functional group makes them to what? To be able to dissolve in water. Why? Because it can form hydrogen bond with water. Their functional group can form hydrogen bond with water because they can exhibit hydrogen bond. That is why they can dissolve in water. Is there your past question? Which of the following bond is responsible for solubility of arcanol or solubility of what? Arcanoic acid in water? The answer is what? Hydrogen bond. Their functional group can what? Form hydrogen bond with what? Water. That is why this derivative are soluble in water. Alkana is soluble in water. Alkana, that is aldehyde, is soluble in what? Water. Why? Because of the what? The functional group which can form what? Hydrogen bond with water. But when you have alkane, when you have what? Alkene, when you have alkyne, this one, they are not soluble in water. They are not soluble in water because they cannot form hydrogen bond with water. They exhibit what? Van der Waals force. This one, that is why they are not soluble in water. They exhibit Van der Waals force when in water. But this one, they are soluble in water because of their hydrogen, because of their functional group can what? Can form hydrogen bond with water. Take note. Take note of that. Let's move further. Let's go to their melting. They have low, another characteristic, they have low melting and boiling point. Boiling point. When we get to what? Each homologous series. When we get to each homologous series, I will explain factors that affect boiling point and melting point of those homologous series. When we get to each homologous series like alkane, alkene, alkyne, and we explain factors that affect their boiling point. But generally, hydrocarbon compounds and some of its derivative, they have low melting and what? Boiling point. Take note. Number 4, they cannot conduct current. Take note. They cannot conduct current. They cannot conduct current. Why? Because they exhibit what? Covalent bond. They cannot conduct what? Current. They cannot conduct current. Please take note. Those are the general what? Properties of what? Hydrocarbon compounds and its derivative, that is organic compound. Then let us move further. Let's move. We know that what is the main source of hydrocarbon compound? The main source of hydrocarbon compound, the main source of hydrocarbon compound is what? Crude oil. We are going to talk on crude oil. The main source of hydrocarbon compound is what? Crude oil. Crude oil is the main source of hydrocarbon compound. Let's quickly talk on crude oil. Okay, let's look at crude oil because the main source, natural source of hydrocarbon compound is what? Crude oil. Hydrocarbon compound can be obtained from animal, it can be obtained from what? Plant, it can be obtained from uh, from animal, like I said. But the main source of hydrocarbon compound is what? Crude oil. Crude oil is the main source of hydrocarbon compound. And what is crude oil? Crude oil is also known as petroleum. Petroleum. Crude oil is also known as petroleum. Petroleum. It is formed from the what? Decay of what? Animal and marine algae. It is formed from the decay of what? Animal and marine algae. Take note. Crude oil is also known as what? Petroleum. And crude oil contains gaseous, liquid, and solid alkane, alkene, alkyne, and benzene, etc. etc. Take note. Crude oil is a typical natural example of what? Of hydrocarbon compound. Hydrocarbon compound that occur naturally. It occurs naturally. Crude oil is a typical example of what? Hydrocarbon compound. And crude oil contains what? Gaseous, liquid, and solid alkane, alkyne, and what? And benzene. Take note. I want you to take note of this. The impurities in crude oil or petroleum are sulfur. Take note, sulfur, mostly sulfur, nitrogen, and oxygen. Sometimes you can have little of what? Metals, and if crude oil contain water, water will be acting as an impurity. Water in crude oil, metals in crude oil, they act as what? Impurities. Take note of that. But the main 3 impurities in crude oil are sulfur, nitrogen, and what? Oxygen. Metals and what? Water in crude oil can also act as what? Impurity. But the main impurities are what? Sulfur, nitrogen, and what? Oxygen. Take note of this. Very important. Very important. Nigerian crude oil. This one came out in Jan. Nigerian crude oil is regarded as light and sweet because it's sulfur free. Take note of that. Because it is what? Sulfur free. When crude oil is light, it is known as what? To be free of what? Sulfur. When you have a light crude oil, that means that crude oil is sulfur free, is impurity free. That means it doesn't contain what? Impurity, such as sulfur, nitrogen, and what? Oxygen. And Nigerian crude oil is regarded as light and sweet because it is sulfur what? Free. That question is in your chat pass question. Take note, take note of that. Please take note of that. Please take note of that. Let's move further. Inside this crude oil, we can obtain so many fractions in crude oil. We can obtain so many fractions in crude oil using fractional distillation. Fractional distillation. Using fractional distillation. We can get so many fractions. That means so many other what? Constituents. There are some constituents in crude oil because crude oil, don't forget, is a mixture. Crude oil is a mixture. Crude oil or petroleum is a mixture. Crude oil is a mixture which can be separated into its component constituent by what? Fractional distillation. If we want to obtain the constituent of crude oil, like kerosene, diesel, lubricating oil, we use what? Fractional distillation. And don't forget, fractional distillation works based on what? Boiling point. Boiling point. Take note of that. Fractional distillation works on this principle, boiling point. The constituent with what? The lowest boiling point will be obtained first. The constituent with lowest boiling point will be obtained first. Fractional distillation is used to separate two or more miscible liquids. In crude oil, we have so many liquids. And if you want to separate them, we use fractional distillation that work based on what? Boiling point. Take note of that. Then let me give you the fractions. The fractions that you can obtain from crude oil using what? Fractional distillation. Their boiling point, their number of carbons, and their uses is very important. Their boiling point, number of what? Carbons, and their what? Uses, very important. The uses, the boiling point, and number of carbons of those what? Fractions, constituents you can obtain from what? Crude oil using fractional distillation. Let me give you. You have this. When you have, in form of table, the name of fractions, Here we have boiling point, that is in degree C. Number of carbons. Then uses. The first fraction you get from crude oil, which has the lowest boiling point. The first one, when crude oil or petroleum is passed into a fractional distillating machine, the first fraction, the first product that will come out is known as what? Petroleum gas. Petroleum gas. And the temperature is below 40 degrees. Temperature below what? 40 degrees. The temperature is below 40 degrees. And the number of carbon is what? It has the range. It's a range. 1 carbon to 4 carbon. That means when you have a fraction of crude oil that has 1 to 4 carbon, that fraction is what? Petroleum gas. This one is used as well in cooking, as well in your gas cooker. It's used in cooking as fuel. Take note of that. And it is used in production of other organic compounds. Take note of that. And the boiling point, you can have petroleum gas when you have boiling point below 40 degrees. you have what? Petroleum gas. And the number of carbon for it is what? 1 carbon to 4 carbon. And uses, it is used as what? Fuel. And in manufacturing of other organic compound. Take note. It is used as fuel, that means in cooking, and it is also used in what? Manufacturing of what? Other organic what? Compound. Take note. When you have petrol boiling point below 40 degrees, you have petroleum gas. The number of carbon is 1 carbon to what? 4 carbon. Number 2, petrol. Petrol. Take note. Petrol is a fraction of petroleum. Petroleum is crude oil. Take note. Petrol is a fraction, is a product obtained from fractional distillating of what? Of petroleum. Petrol is a product. Petroleum is the crude oil. Take note of that. Petrol. And petrol, it is obtained when the temperature is between 40 degrees C to 200 degrees C. And the number of carbon for that one is what? C4 to what? C12. The number of carbon is C4 to C12. C4 to C12. The number of carbon is C4 to C12. It is used as what? Fuel in airplane. And it is also used as fuel in what? In motor vehicle. It is used as what? Fuel in what? In airplane and in motor vehicle. Take note of that. When you have carbon between what? 4 to 12 and temperature boiling point between 40 degrees C to 200 degrees C, that means you have what? Petrol. Take note of that. Number 3, we have kerosene. The temperature is between 200 degrees C to 250 degrees C. And the number of carbon is C12 to C18. Can you see? As the number of carbon is getting higher, what happened to the boiling point? Getting higher. That shows that the boiling point of hydrocarbon compound increases as molecular mass increases. Take note of that. When we get to what? Factors that affect boiling point and melting point of hydrocarbon, I will explain. But take note of that. Boiling point and melting point of what? Of hydrocarbon compound increases as molecular mass increases. Can you see? As the molecular mass is increasing, can you see their boiling point is increasing. Take note of that. This one can also be used as what? Fuel for eating. For example, you will use what? Kerosene for fuel, as fuel for eating. If you want to cook your rice, your beans, you use kerosene in your stove. It's what? It's fuel for eating. To eat your what? Your pot and to cook your what? Beans. It's used as fuel for eating. It can also be used as fuel in jet engine. Take note. It is used as fuel for jet engine or in jet engine. Any which one for jet engine. Number 4, we have diesel. We have diesel. The temperature is between 250 degrees C to what? 350 degrees C. That means for diesel, we have that 250 degrees C to what? 350 degrees C. And the temperature, the number of carbon is from what? C12 to what? C25. Diesel. And diesel, take note, this one come out in jam. It came out last year in jam. Take note, one of the uses of what? Diesel. It is used as a fuel for diesel engine. engine. And it is used, this is the question that came out, this is the one that came out, as what? Raw material. Raw material. Raw material for cracking process. Cracking. It is used as raw material for cracking. I will still give you the meaning of cracking in this video. Cracking is also known as pyrolysis. It's a jam question. Another name for cracking is called pyrolysis. 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 That means breaking down of large hydrocarbon into smaller hydrocarbon. I will now tell you, I will give you the uses, or one of the uses of cracking according to jam. Take note of that. That means you have diesel, the temperature is 250 to 350, and the number of carbon is 620 to 625, and it is used as what? Raw material for cracking process. Take note. Next one, number 5. This one also come out. Lubricating oil. Lubricating oil. The temperature is from 350 degrees C to what? 500 degrees C. And the what? The number of carbon is above 20. Above 20. When you have number of carbon to be what? Above 20. And this one, lubricating oil, can be used in production of candle wax. Candle wax. It can be used in production of cream. It can be used in production of hair cream. Take note, hair cream. Take note. And it can be used in production of lubricating oil for moving part of engine. Lubricating oil. Lubricating oil for moving part of engine. For moving part to prevent wear and tear. For moving part of machine. For moving part of machine. Take note. For moving part of machine. Take note. Number 6, which is the last one, we have bitumen. Bitumen. There's a question on this. The temperature is above 500. Number of carbon above 35. Above 35. It can be used in construction of roads or the surfacing of road. Construction of road or the surfacing of road. If you want to rehabilitate road, we use bitumen. And take note, the question that came out of bitumen, that one of the uses, that it can is the only, take note, is the only solid fraction of what? Crude oil. Take note. Is the only solid fraction of what? Crude oil. Is the only solid fraction of crude oil. Bitumen is the only solid fraction. Is the only solid fraction. Fraction of crude oil. Bitumen is the only solid fraction of crude oil. Which, if they ask you, is there your past question, which of the following fraction of our crude oil can exist in solid state? The answer is what? Bitumen. Take note of that. Next one. Yes. Okay. We have what we call cracking. Another name for cracking is what? Pyrolysis. Cracking is the breaking down of large hydrocarbon compounds into what? Smaller hydrocarbon compounds. The breaking down of a large hydrocarbon compound into what? Smaller hydrocarbon compound. And to have one saturated and what? Unsaturated hydrocarbon compound. I say, is the breaking down. This is the breaking the breaking down of a large hydrocarbon compound into smaller hydrocarbon compounds, either by heat or catalyst, to have one saturated, okay, I will explain this, either by heat or catalyst. When it is done by heat, it is known as thermal cracking. When cracking is carried out by heat, it is called thermal cracking. When it is carried out by catalyst, it is called catalytic cracking. Catalytic what? Cracking. It is called catalytic cracking. When it is done by catalytic cracking, by it is called thermal cracking. And take note, during cracking, there will be production of one saturated hydrocarbon, HC hydrocarbon. When those smaller hydrocarbons, one of them will be saturated, then two unsaturated hydrocarbon compounds. During cracking, when you break down large hydrocarbon compound into smaller hydrocarbon compounds, when you break down a large hydrocarbon compound into smaller hydrocarbon compounds, either by heat or catalyst, you will have one saturated means for one single bond, then two unsaturated hydrocarbon compound. That means two unsaturated hydrocarbon compound, which could be what? Two double bond, or one double bond, one triple bond. When you have cracking. And one of the uses of this cracking is that we can furtherly break down large fraction of crude oil, such as what? Kerosene, such as what? Diesel, to obtain what? Petrol. Because of high demand of petrol, we can furtherly break down kerosene using cracking method to get petrol. We can furtherly break down what? Diesel to get petrol. That means cracking is used to increase the availability of what? Petrol. Take note of that. Is there your past question? Cracking is used to increase the availability of what? Of petrol. Further breakdown of what? Kerosene or diesel will give you what? Large quantity of what? Petrol. Now this cracking is used to what? To increase the availability, to make what? Available petrol. Take note of that. Is there your past question? Cracking is used to what? To make available of what? Of petrol. To increase the what? Availability of what? Petrol. Take note. Further breaking down of kerosene and diesel will give you what? Petrol. Further cracking of kerosene and petrol will give you what? Of kerosene and diesel rather. Further cracking of kerosene and diesel will give you what? Petrol. Take note of that. Then let's move further. We have what is called catalytic reforming. Catalytic reforming. This is jam question also. Catalytic reforming. Reforming is to improve the what? The performance of what? Of petrol. Reforming is called catalytic reforming. It is done in the presence of catalyst. Catalytic reforming. It is an isomerization process. Take note. isomerization process. It is an isomerization process. Reform me. It is an isomerization process, and it is used to what? Improve the performance of what? Of petrol, to prevent what? Knocking of engine. Take note of that. It is used in what? In improving the performance of what? Petrol, to what? To prevent knocking of what? Engine. That is catalytic what? Reforming. It is an isomerization what? Process. That means when you have long chain alkane, you make it to be what? Branched. To have what? Branched. That means you've improved the what? The performance. You've improved the what? The liquid. When you have what? Long chain petrol, you now want to improve the long chain petrol, not to make it what? Knock an engine. That means it will undergo what? Catalytic what? Reforming. Catalytic reforming is an isomerization process. It's just a way of what? Improving the what? The performance of what? Petrol, to prevent it from what? Knocking an engine. And we have what is called octane rating. Octane rating. Octane rating. Before we move, let me just talk on octane rating. Octane rating shows the performance of petrol. Octane rating shows the what? The performance of petrol. If you have a straight chain petrol, for example, octane, a straight chain hydrocarbon, such as octane, which is CH3, CH2, 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 1, 2, 3, 4, 5, CH2, CH3. This is straight chain. This one, the octane rating of this one is what? 0. This one, the octane number assigned to this octane is what? 0. If you have petrol that have what? Straight chain what? Octane. That means the octane rating is what? 0. This one can knock an engine. The octane rating is what? Very low. To have a high octane rating, the hydrocarbon must be what? Branched chain. It must be what? A branched chain hydrocarbon. Therefore, if you have this 2,2,4 trimethyl pentane. This is what? 2,2,4 trimethyl pentane. The octane rating of this one is what? 100. 100. This one cannot knock your engine. This one is good for your engine. Why? Because it has what? Branches. It has what? Branches. It's different from this one, straight chain. Straight chain hydrocarbon is not good for an engine. It has octane rating of what? 0. But when you have branch chain hydrocarbon, it cannot knock your engine, such as what? 2,2,4 trimethyl pentane. It has octane rating of what? 100. Take note of that. And there's a substance that is used in preventing what? Knocking of engine. It's called what? Anti-knocking engine or substance. Take note, we have tetraethyl lead. Tetraethyl lead. Tetraethyl lead. C2H5 tetraethyl lead. It is used in prevention of what? Knocking of engine. Take note. It is used in prevention of what? Knocking of engine. Tetraethyl lead. It is used in prevention of what? Knocking of engine. Please take note of that. Please take note of that. Please, I will advise you, please help us to what? To subscribe to this YouTube channel, comment and what? Share it to your what? Friends. And at the same time, we need your donation. If it is what? No amount of money is too small, for more video on what? Organic chemistry and other what? Topics in chemistry and topics in physics, topics in what? Mathematics, biology, and English. Is we need your what? Financial support. Nothing is too what? Small, and nothing is too what? Big. On the screen, you will see the account number you can pay into. Thank you. May God bless you.